In this video, I'm going to teach you how the code works that makes the robot perform certain actions based on the specific color of the LED. Open the Robby led.ino file in Arduino IDE. Once again, locate the file name Robby led.ino on your computer and double-click on it to open it, or simply click on File and then Open and navigate to the specific folder that contains the file robbyled.ino. Once you have this file open in Arduino IDE, it should look like this. Note that the first line of code is an include statement. It says include servo.h. All this means is that we want to use the code library for servo motors. Oftentimes, the manufacturer of the microcontroller unit also provides some pre-written library of code files. This makes it easier for us to simply include those libraries in our program. The servo.h library of code allows an Arduino board to control servo motors. As you may remember, I am declaring the number of servo motors we are using. As you know, we are using 3 servo motors, so the 3 lines of code simply gives each motor a label. You could use any label name you want, but I encourage you to use descriptive names for the labels so that it's easy for you to know what it refers to. The 3 labels or names I used are head servo, left arm servo, and right arm servo. Next, you see int LED1 red equals 5. This indicates that red LED is connected to pin 5 on the microcontroller unit. Similarly, int LED2 yellow equals 6. This indicates that yellow LED is connected to pin 6 on the microcontroller unit. Finally, int LED3 green equals 7 indicates that green LED is connected to pin 7 on the microcontroller unit. I am also declaring a new variable, POS, as an integer that I will use in my for loop later in the code. Remember, we used h as a variable previously, and this is just another variable with a different name. Next, I have what we call the setup section, which starts with the label void setup. This section of the program is typically used to set up the initialization code, such as specifying which pin a specific motor is connected to and setting the motor position. First, we are going to tell the program which motor is connected to which pin on the microcontroller board using the command named attach. It is very important that we assign the correct pin in the code to match with the physical connection we made for the motors. As you see, we are now telling the program that the motor connected to the head servo, is connected to pin number 2 on the microcontroller board. The number 2 in parentheses after attach is the pin number. So, head servo.attach 2 means that the motor connected to the head is attached to pin number 2. Remember, that's exactly how we connected it when we were connecting the wires from the motor to the microcontroller unit. Next, we are telling the program that the motor connected to the left arm servo, is connected to pin number 3 on the microcontroller board. Once again, the number 3 in parentheses after attach is the pin number. So left arm servo dot attach 3 means the motor connected to the left arm is attached to pin number 3. Remember, that's exactly how we connected the left arm motor when we were connecting the wires from the motor to the microcontroller unit. Next, We are telling the program that the motor connected to the right arm servo, is connected to pin number 4 on the microcontroller board. Once again, the number 4 in parentheses after attach is the pin number. So right arm servo dot attach 4 means the motor connected to the right arm is attached to pin number 4. And remember, that's exactly how we connected the right arm motor when we were connecting the wires from the motor to the microcontroller unit. In the next 3 lines of code, we are simply setting the initial position of each motor, in the same way we did in the previous program, but now to different positions. Head servo to 90 degrees using head servo dot right 90, left arm servo to 180 degrees using left arm servo dot right 180, and right arm servo to 0 degrees using right arm servo dot right 0. The command pin mode tells the specified pin to behave either as an input or an output. In our case, we are going to use the pins as outputs. So we are telling the program that we want to use the specific pin as an output using pin mode LED1 red output. So the LED1 red, which was set to pin number 5, is to be used as an output. The code line pin mode LED2 yellow output sets LED2 yellow, which was set to pin number 6, to be used as an output. Finally, pin mode LED3 green output sets the LED3 green, which was set to pin number 7, to be used as an output. That pretty much completes the setup section. Please note that after each line of code there is a semicolon. That is required as it is part of the structure or syntax of the program. It's similar to the way we use a period at the end of each sentence. Also note that this section of the code starts with the symbol open bracket, and then this section closes with the close bracket symbol. This again is part of the structure of the programming language. The next section of the program is called the void loop, which starts with the open bracket and it closes with the close bracket. This is the main program that gets executed. This is the section where you write the main code that's going to make the robot perform certain actions. First, I want to turn the red LED on. To do this, I use the code line digital write LED1 red high. The command digital write is used to issue a value of high or low to a digital pin. In our case, we are writing high, which turns the LED on. Then, the program performs the left arm movement. It starts the motor at position of 180 degrees, which is straight down. It waits 10 milliseconds and then reduces the value of the variable POS by 1 to 179 and issues a command to bring the motor to 179 degrees and waits 10 milliseconds. It starts another cycle by reducing the value of POS to 178 and issuing a command to bring the motor to 178 degrees and waits 10 milliseconds. It continues to repeat this loop until the motor position reaches 0 degrees, which is where the left arm is straight up. It waits 1 second since the code says delay 1000. The program then starts another similar loop where it lowers the left arm from 0 degrees, which is all the way up, to 180 degrees, which is all the way down. This is how the left arm moves while the red LED is on. Next, I am simply turning the red LED off using digital right LED1 red low. Note that low means turn the signal to the specified pin off, which turns the LED off. It then waits 1 second since it says delay 1000. The next section of the code turns the green LED on, and then the robot performs the right arm movement. Once it completes the cycle, it turns the green LED off. This is very similar to the previous code where we turned the red LED on, perform the left arm movement, and then turn the red LED off. Remember that 180 degrees for the left arm was straight down, but because of how the motors were attached, 180 degrees for the right arm is straight up. As you see, digital right LED3 green high turns the green LED on. Then the for loop creates the right arm movement. It starts the right arm at position 0 degrees, which is straight down, and goes all the way to 180 degrees, which is straight up. It waits 1 second. It then lowers the right arm from 180 degrees position to 0 degrees position. Next, I'm simply turning the green LED off using digital right LED3 green low. Note that low means turn the signal to the specified pin off, which turns the LED off. It then waits 1 second since the code says delay 1000. In the next section of the code, I am turning the yellow LED on first. Then it performs a head movement, and then finally I am turning the yellow LED off. As you see, digital right LED to yellow high turns the yellow LED on. Then 3 for loops create the head movement. It starts the first loop with the head at position 90 degrees and goes down to 30 degrees. It waits 1 second. The second loop then moves the head from 30 degrees to 150 degrees. It then waits 1 second. Finally, the third loop brings the head from 150 degrees to 90 degrees. Next, I am simply turning the yellow LED off using digital right LED to yellow low. Note that low means turn the signal to the specified pin off, which turns the LED off. It then waits 1 second since the code says delay 1000. That's all. Easy, right? To summarize, the code starts with declaring the variables and naming the motors. The code inside the void setup section first tells the program which pin on the microcontroller unit that the motors are connected to, and sets the initial motor positions. It also states that pin numbers 5, 6, and 7 are to be used as output pins. The code inside the void loop creates the movement of the left arm, the right arm, and the head based on the specific color of the LED that is on. Please feel free to watch this video again if you didn't quite understand the way the code works. As I mentioned before, learning how to code takes practice, so don't feel bad if you didn't understand it. I have written the code in the simplest way to make it easy for you to follow along and understand, but feel free to watch the video again if necessary.